me again. Here, I would like to share my curiosity about gravity. Okay, so as we know, Isaac Newton discovered gravity, right? Let's just write Sir Isaac. Okay, Sir Isaac Newton. Okay, he discovered gravity, which the value is around 9.81 meters per second squared. Okay, the value of gravity, the strength of gravity here on Earth. And again, it differs from planet to planet. Okay, different gravities. Now, he discovered gravity by when he was sitting down and under an apple tree, and then an apple fell down on his head. So he became curious. Okay, so there's a story you can read about it. And then, but he didn't manage to explain how gravity works. So there came Albert Einstein. There came Albert Einstein, and he explained how gravity works by, like a trampoline, for example, because he said gravity is the what you call this, the warping of the space-time fabric, similar to when you stand in the middle of a trampoline, it will be depressed at the center. Okay, it will be depressed at the center and try to throw a ball to rotate like a roulette, to rotate around that center, which is depressed. Okay, there's a depression in the center, so it will rotate. The ball that you have thrown, it will revolve, and you will see after some time it will revolve closer and closer to the center. So that's how he explained gravity. Okay, in which in our solar system it's the sun, which is the massive body in the center that warps the space-time fabric, and then that caused the planets to revolve around it with a certain gravitational pull. So that's how Einstein explained it. But then when I try to question it again, I want to know what gravity actually is. Is it like a particle? Is it just lines, or is it just the wind? I don't know. So as I've mentioned in my other video, I don't like to read too much. I like to think of it first, and so that in that way I could have a friendly debate with other person. So here's what I've read way back before. I think it's in 2014, 2015. I'm not quite sure anymore, but I have the video of me typing that in Microsoft Word and on my laptop, because I've also asked this question on the internet from the what was that website, askascientist.com, but then unfortunately they didn't answer me. Okay, so I made an evidence or proof that I've asked that, so that I can have the reference. So here's what I read. There are scientists that tested or conducted an experiment in their laboratory, in which they managed to lower down the temperature of this certain fluid. They lower it to 4 kelvins. Okay, they managed to lower it in they managed to lower it to 4 kelvins. That's basically, if you convert it, I think it's around negative 269 degrees Celsius. Okay, because the conversion of 0 degrees Celsius, it's actually 0 plus 273 kelvins. Okay, So that's what I read, and they said, okay, they have concluded that it began to defy gravity. It became a superfluid. So first, it has, gravity is acting on it, and it stays on the container. But then when they cooled it down to this temperature, it became a superfluid and floated. Okay, it defied gravity. So it made me think, how if these gravity, okay, is that are actually lines, okay, very close lines, very close lines. So how? Just try to imagine. Like for us now, we have a certain temperature, okay, our body temperature. So any object will have a temperature, so that it will have energy, okay, internal energy like kinetic and potential energy. So it will be vibrating, right? Okay, pardon me with my hand gestures. It will vibrate, okay? Things will vibrate if they have energy. So objects are made of particles, small particles, okay? That one I will explain in another video when I discuss about chemistry. So those particles vibrate, and those particles have spaces, even though they are closely packed, but they still have spaces, okay? Let's say it vibrates, and those are the spaces, okay? And then gravity are lines, okay? Think of it as lines projecting, okay, projecting downwards, okay, to the center. So if the particles are vibrating, and then the gravity push it down, it will hit it and eventually push it down towards the center, okay? But then when objects have this temperature, which is really close to absolute zero, okay? Absolute zero is 0 kelvins, in which it doesn't have energy at all, okay? So if it doesn't have energy at all, it will not vibrate. So for this temperature, it will only vibrate really minimal, okay? It will like almost not vibrating, and then they have spaces, and then the gravity lines will just penetrate through it, okay, between the particles, and therefore it is not affected by gravity, and it will not the gravity won't push it down. So that's why it floats. So that is my thinking, okay, on my theory about it. I could be wrong, okay? So this one I still want to read, okay, if I could find more references, and if I'm given the chance to try and conduct an experiment in any university, I would like to prove it or disprove it, okay? So that's all for my curiosity and about gravity. I hope you like it. Please hit like and subscribe. Thank you.